Hello, welcome to episode 4. I'm Neil Millard, and we are on our journey of creating a container management system or container hosting system, CHaS, as we're calling it here. So, I've been on a journey of discovery this week about all sorts of stuff like grpc and things. And this is because I'm interested in programming, I love learning, and I forgot what we were doing, mainly because of what we're doing. We're doing an MVP, a minimum viable product. This means we want to do the minimum required in order to get our product actually working and functional. And right at the beginning of this project, I decided that we were going to use nerdctl in order to do that. Nerdctl is a command line, a Docker replacement command line, which means we don't need to know anything about containerd, grpc, runc, or any of that stuff, because we can just run this instead. And by going down that rabbit hole, which was, somewhat enjoyable, because now I know what grpc actually is not really helping us get to a working product, because we want to do this stuff. So how did we end up at this point? Well, I'll tell you. We were trying to get to the point where in our client we were just about to jump onto sync, and under sync it requires a certain request. Actually, I don't know why that's not in there. Let's go down here. So sync requires a request. It's not a register request. No. It's a sync request, obviously. And it returns a sync response, probably, because that would be reasonable. Is there such a thing as a sync response? No, there isn't. Okay, what did I call that? If only we had our model and it could tell us. So we got our sync request. Yeah, there is a sync response. I thought it was. See, it's not going mad after all. Where was I? Oh, we're in the client. We're in our API client. And yes, it does reply with a sync response. There we go. Just completely confusing me. Right, what is in a sync request? We've got the agent ID, which is the same one we send when we register. We've got timestamps, so know where we are with relation to anything else, and then we've got resources. So agent resources is where we got to. In agent resources, we want to tell the API how much CPU we've got available, how much memory we've got available, and how many containers we have running. And as an option, how busy the CPU actually is, because whilst we can allocate CPU, that doesn't necessarily mean that all the containers are using the CPU they've been allocated. And so in order to help us get this, we developed a system utility file, which tells us stuff like how many CPUs we've got, how many are free, and the total memory and the total free memory. And this is where we got stuck here. Get allocated CPU cores from containerd. Now, we don't need to get it from containerd. We can get it from nerd instead. So this means we want to do something like, well, it's going to be something. So naming things is hard. It needs to be a client that will interface from us here to all of the container stuff. So this means we want, if you like, a container client. Now, I don't want to call it nerd. I don't want to call it containerd, because that's implementation detail. So a great thing about programming is we can abstract stuff. We can abstract stuff away from what we're actually doing. What the hell do I mean by that? Okay, well, let me give you an example. when we're talking to a container, we only want to do a certain number of bits to a container. So I've defined here a container operations class. So this is the things, the operations we want to do to a container. We want to start it, we want to stop it, we want to delete it, and we want to get the container status. We actually want to get container info as well. So let's no, we don't want logs. That's a very nice suggestion. Thanks for that, whichever model you're telling us. But we want to get info. And yes, it should have self, and then we want the container ID, which is a string. And at the moment, it's suggesting we return back a dict. We're not going to return back a dict. We're going to return back something else. It will be a model, because then we can know what it looks like. Otherwise, a dict is just a dictionary. In this case, it's a strings and any, and we have no idea what that is. If we've got an actual model, it means we know exactly what it is. It means that we can define precisely what data is in that structure, and therefore we can handle it. And more importantly, our IDE can track what types we're throwing in there, and we can catch some really easy errors early on, because our ID will help us with what's going on. Now I'm going to change these to CID because container ID, and there is an internal thing called ID, which is what my ID will constantly whinge about if we don't do that. Anyway, so we're going to come back to this in a minute, but ultimately we've got a container class here. This container class is going to say, hey, here's a container, there's a container ID, it has a client which is container operations, and it's going to start, stop, delete, and get the status, which is precisely what we're after. And it's going to conform to the container operations model, which is here. And then we've got this thing, which is the client. And so it's the client's job to actually implement the detail about how we do all of that gubbins. And at the moment, it is using some naming conventions that imply that it's going directly to container D, which we do not want to do. Now we can do whatever we like in this file as long as it implements the container operations stuff. So let's get rid of all of this. This is very nice code that AI generated, but there's a few bits in it. Actually, there was a bit to note in here. Where is it? Oh, I got rid of the import. If I put that import back in, there it is. Let's put these imports back in again. What I'm going to show you is here. So I could tell you all about grpc, but I don't want to. I'm trying not to because we don't need to know it. But my ID has quite helpfully highlighted this in yellow, which tells us that it looked in here and that function does not exist. Likewise, it's looked in here and that function does not exist. The AI has hallucinated. Now, AIs don't hallucinate. They only tell you stuff that they've already seen before. Yeah, it can't make stuff up, which is funny because then people say it's hallucinated, it's made stuff up. No, what it's done is it's made a best guess about something else. What I'm getting at really is there is on the internet a piece of code that does say grpc image.pull. That phrase actually exists. It's on the Go client for the container D, and that's fine, but it's written in Go. It's not Python, and it's not in the Python library, which is why my Python IDE said no, that doesn't exist, but it does exist in the Go library. In fact, rather disappointingly, we are importing the Pi container. Let me just show you here. Too far down. Where is it? In our project TOML, we're importing container D, which is a Python package, obviously. Apparently it's not installed. That never works on my IDE. Never mind. And they were doing it in Python for ages and ages and ages. They being Siemens. And then they decided to just switch to using a Go client because it's easier. Container D give you a Go client. Why would you not use that straight away? Because we're doing this in Python, that's why. Anyways, so we might end up going down the Go client route at some point, who knows? But for today, we're doing everything in Python. So here we've got our container D client. So we're not going to call it a container D client. In fact, I'm going to get rid of this entirely. I'm going to borrow this line here a minute. That's container operations, and they're okay. It's here. Like, it's already here. We're fine. We're all fine. So when we are in here, this container level, it only cares that that the client is a type of container operations. Container operations, if you remember, is here, and we've defined it at this point. What the heck's protocol? Now I'm nervous what protocol is. It's a base of protocol classes which does static type checkers that recognize all of that duck type. Oh yeah, okay. Yeah, I guess that's okay. The other way of doing it is an ABC, as you can see up there. An abstract base class. I know, right? That's possibly the better way of doing it, because it is an abstract base class, but at the same time it's an interface, which is why it says it's using the word protocol rather than interface. Anyway, very confusing, getting distracted as we do. So we're going to, in container here, this is too high level. This is when we're talking about an actual container. I'm having to design on the fly here. Let's just take a drink. What I'm looking for is this. We want to define a client that fulfills all of the container operations. And why do we want that? We want that because we want to inspect the container so we know how much CPU's got allocated to it. Yeah, it's quite a big rabbit hole, I know. So, right, let's get rid of this because this has got a load of implementation detail in. Nice as it is, but its implementation detail shouldn't be here. So yeah, this is quite literally an abstract class that just says use this client. It's not an abstract class, it's a real class. Use this client and then it can do all of this stuff to it. And so when we get a container, this is what we will reply with. And to get a container, we need to list the containers. So in our helpful test down here, we've got test nerd. So it says get all containers and get the container info. So the first thing we need to do is find all the running containers with something, and then for each container we've got, we then need to go get its information. So this sounds fair enough, and it's helpfully called test nerd. So let's get nerd here. We are wanting to create a get all containers function, aren't we? So let's create a class and this is where it gets complicated. So I'm going to call it nerd just because that's what it is. Now nerd doesn't need anything other than its own sense of sanity, which I'm quickly losing, but we'll have a thing and then get all containers. Okay, that's reasonable boilerplate, and get container info, which I think matches this. It's like it's reading my code and it's giving it back to me. Isn't it a tinker, right? So when we find all containers, what do we actually want to happen? We want a list of container IDs. That really is all we're worried about right now. So we can so the standard way to do a test would be given, when, then. That's one way of, no, then, stop helping me, is a way of defining a test. So given these, or this situation, when we do something, we then get something else. So as an example, we can say our running images is going to be, and we got a dict here, so we've got, actually it's not going to be a dict, is it? It's going to be a list straight away. So it's going to be a list, and in each list here we want to return back a container, right? So it's going to be a container that's then going to have an ID and a client, because that's what we've designed our container class to do here. It gets an ID and it gets a client. Lovely job. So that's what where the heck am I? Oh yeah, that's the actual function itself in the test. So the test wants to give us back a container. Is it container? Really? Might be. container. Yeah, it is. It should have source on the front of that though. I don't know why that path's not working. Something in my ID that's set up, right? This should be CID because of course it is, and then a client. So we're all going to give these the same client. We don't actually care about the client right now, so that can just be a magic mock. It doesn't matter, it's just a thing. And then we want a bunch of containers, so these are just going to be strings, right? And hexadecimal strings, like beef. That's a good hexadecimal string, isn't it? And then we're going to have another one. Chicken. Okay, that's not hexadecimal, but it could be chicken. Funny. Okay, so this is our given statement. So given that we've got some running images, then when we call the given images, so it's going to be client containers list. I mean, that's right, but that's not there. That's in here. In fact, yeah, that probably is in there. We'll check that in a minute. I'm not convinced that that's exactly the right path. But we then want to call in our nerd class get all containers. Containers. We're going to call it got containers. That's probably horrible, but naming things is hard, like I keep saying. We don't want to create a function, we want to import it. So somewhere around here, we're going to do from source dot container dot nerd import nerd, and then this will be, see, does it need to be a class? That's a very good question. I mean, this is in test nerds, this is fine. In which case nerd needs to be a new nerd. So this command here is going to call the constructor, the init. That's all it does. And as it's empty, it doesn't do anything, and then it returns a object of class nerd. And this means that when we call nerd containers, it's got all containers on it. So if I click on that, it'll take us straight to this function here, which is exactly what we expect. Okay. So given that we've got a client, given that we've got a nerd class, and we've got some running images, we're going to fix this in a minute. But basically this says when we call the client, it's going to give us back a list of all the images, and then our get all containers. Let's call that containers. Will that clash or anything? No, probably not. Okay, so when we get back containers, we then want to, which is our then statement, assert that containers is running images, which is lovely. I'm not sure why have I called that running images. Hey, what the hell? No problem. Okay, so we come back to this statement here. So we've got our client. In our client implementation, it needs to be a type of, I don't know actually, it needs to be a type of container operations. So container operations at the moment says start, stop, delete, get status, and get some info. So we're actually going to add in another one, which is get running containers, which will be self, and that's all it needs because it's just going to get everything. Now under the hood, because I've been on this great big exploration, I know that there's some stuff called namespace. Namespace you might have seen when running a container. Docker, for instance, when it speaks to containerd, always starts all of its containers under the Moby namespace. We can chuck it under the CHaS namespace if we want, but it's always going to be a constant, so it doesn't need to be passed anywhere. All we need to know is it is a thing. Right, so get running containers, is that the best thing to call it? I mean, here it says get all containers, which is not the same as running. Yeah, I'm thinking get all containers is probably better because our client is going to be doing that. Right. So this needs to be get all containers, whether they're running or not. If you remember, a container is a thing with a file system attached to it. So you have an image, you can create a container, and then we can create a task, and then we can start the container with the task, which is a bit like starting the container. But containers can be paused and they can be stopped. And so we might want all running containers because they use up CPU, but I'm thinking paused containers might actually use memory as well. So we probably want to get all the containers, and then we can just get all of the allocated resources that they have to them. So let's change this to See, running is not the right word anymore, is it? It's not running containers. I mean, we can leave it running containers for the test. We can expand the test later to say, oh, did it spot any stocked containers as well? Who knows? Okay, so where were we? We were here. We were looking at our client, which is a magic mock. Now we can tell magic mock to base it on something. So we can tell it that we actually want it to base it on container operations, which is handy. Can I remember how to do that? That's obviously too easy. It might be that. We'll see. We'll run the test in a minute and it'll fall over in a heap. I got a feeling there's a special thing. Yeah, it's a magic mixing or a mock. If you use the spec or spec set arguments, then only magic methods that exist in the spec will be created. Okay, so actually what we want to do is spec equals that. There we are. Although I don't think we even need that. I mean, let's get rid of that. Okay, the point is that our client is going to have the thingy here, which is called get all containers. So in our test, when we've got a client, we won't be calling containers list return value. We will be just calling get all containers. I suppose the reason why AI's thought that we might want to do it the other way bears some thought. So in the client, note in the operations, this could maintain a list of images that it already knows about, and then it could just straight up return that list straight away. And that would be nice, but it would be caching it. And unless we know that we are in charge of everything that's happening, that cache might run out of data, might be stale very quickly. So I'd much rather go get the fresh information every time we're asked for it, because containers can stop at any point. And if we just said, hey, start container, and then we assume that it's still running, then we might be running off of stale data, and that will cause all sorts of strange issues. Anyways, so client, get all containers, return value, running images. So this is not right either. Is it? It is. No, this is right. So however the client manages it, we want it to return a list of containers like this. Why is that? Expected type container operations and got a magic mock instead. Yeah, so this is why. If we put the spec equals container operations, does that go away? No, it doesn't. Okay, in which case we don't need to create a magic mock. We can actually give it a real one. But we don't want to give it container operations. We want to give it the nerd function, which at the moment isn't based off of that. So this needs to be container operations. There we go. Right, now it's going yellow because this type of get all containers is incompatible. Probably because it's returning nothing. That's what it's complaining about. Now, does this actually say? No, it just tells us it gets all containers, returns null. If we look at the spec says, the spec says it returns nothing, which is obviously rubbish to start with. I'm expecting my IDE to be a little bit more helpful than that, and it clearly is not. Get container info is incompatible. Yeah, I think that's because it requires a container ID. Although even then it's whinging. Why is this complaining now? Oh, it's because it's async, that's why. Async is a conversation for another day. That's why. Now, if it was an ABC, it would be complaining all over the place, saying you've not implemented all of the things. But because it's defined as an interface, it doesn't care so much at this point. But we probably should care. We probably definitely should care. Anyway, so get all containers at the moment returns nothing. So we could tell it to return an empty list. And in fact, I'm going to tell it that it returns a list of it is actually a dict. It's actually a dict, isn't it? Because no, it's not. It's a list of containers. Right? Okay, sure. That's fine. So it's not a list of strings. It's actually a list of container. Like that. And an empty list is valid. Okay, great. And our client is. We're going to give it a real one. Oh, no, is that right? No, that's not right. Oh, now I've confused myself. Nerd is nerd, which also has a client, which is nerd. Really? I mean, that is true. I wonder if that breaks. I don't know. Let's try it. We can try these things. Because then we can call nerd directly. Because that's what we are doing. We can get all values, blah blah blah. Yeah. So get a nerd class. Run images is that. If we call get all containers, it should return the running images, which is a list of containers. And then containers equals nerd get all containers, and it should return us the list which should match that, which at the moment it doesn't. At the moment it will return an empty list. So if we run all the tests, let's see what actually breaks. Look at that, we've got 2 failing tests. We got the one I expected to fail because method has an attribute return value. Right, okay. That's because we need to mock some stuff. This is where if we do the spec of container operations, it's not a magic mock anymore. Because it's a real nerd. This is why I wanted to use a magic mock. Okay. Magic mock it then with the spec of that. Okay, let me explain what the spec does. We could here do get all containers equals magic mock. Okay, which then sets out to a magic mock. And then if we didn't have this line, we can then do, yeah, exactly what it said there actually. Nerd get all containers equals get all containers, which then assigns that magic mock to that call. But allegedly, if we just do that, it should spec them all for us. It will look at that and it will go, right, this function here needs a magic mark, this needs a magic mark, this needs a magic, exactly, as we go down the list, right? So if we run the test again, it should now fail, but for a different reason. Yeah, coroutine blah 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 doesn't equal that. Right, okay. That's because it's a coroutine, which it really is. Hang on, where's our test file? That's because this should be a wait. So whenever we call an async function, we need to await it. And whenever you call an async function, you need to make sure you are indeed inside an async function as well. I said async is going to be confusing real quickly. So it should have still failed. It did fail. No, it didn't. Oh, right, it says we need to install a suitable plugin in order to do that. That's fine. Let's do that then. No, we don't want PowerShell. We want the proper one. Make sure we're in the right folder, which is agent. Really? What? Bear with. I can definitely see some files here. Oh, right, okay. We've got components folder in the middle. That's why. There we go. Okay, uv add --dev, because we don't need it when we're running the real code. There's my paste option. There it is. Async IO. Right, that's now in there. Good. So now I should run the tests. We now know what sync and all that malarkey is. Don't know why it keeps hiding that. I just did. You're inside the right virtual env. It says CHaS components agent, venv. That's where we quite literally were, and we've installed it. I'm going to run it again just to see if there's any further error messages that I missed. No, it's just saying async def functions are not natively supported. You need to import a plugin for your framework. PyTest. Do I need to import it or something? Import. Yeah, probably need to do that. I mean, it's there. Nope, it's really not happy about that, is it? I'm curious why that's broke. I swear we fixed that in the last video. I mean, we don't have to make it async today. Yeah, so here we get that. Yeah, that was probably true as well. Ooh, we shouldn't have that in there. Oh yeah, we've got that error again. Which I fixed by having the PyPath set correctly. But when we set the PyPath correctly, now we don't have async IO, which is definitely in the VNs that we're looking at. There is a mod packages, Python packages. It should tell us what's in here. Yeah, see, that says Boto and all sorts of stuff in here, which we don't have anything to do with Boto in here. Why does that think is empty? Go to the tool window. Yeah, we did. Select the package. Loads of gubbins. See, now I'm confused because that's given me one list. And this, so this is what it should look like. Is if we go into lib, we've got all of these here. You know, so we do have Google, which is fine. But you'll notice that Boto is not in that list, but it is in this list, which is really confusing me. But that's why it doesn't think stuff is installed. Is it looking? Yeah, that's the one it should be looking at. Alright, let's delete it and set up again. Add local. It already exists. You're damn right it already exists, but I don't want you to go there. It's UV, and it is components agent VM. There we go, in there. And then scripts, and then Python. Now it says 314 rather than 312, and then it says 313. It's remarkably confused, isn't it? But it still doesn't say we got much in there. Right, update Python interpreter. That helped, didn't it? And in theory, it's just reading all these packages in. In practice, it looks like it's got very confused. Let's run the test again, see what happens. Oh, my ID is not happy. Okay, let's look at the settings here. Now, I seem to remember that what it can do is we can point this at a completely different thing. You need to install the thing. Yes, let's have a look at all the skeletons now, but that shouldn't stop the test from running. It might, but it shouldn't. Man, sorry, this is a bit boring. That's where I expect it to be. And the only thing is that when I ran the UV command, that's a good point actually, did it actually put it in here? It did. It did actually put it in here. Okay. Let's do things the hard way then. Is it deactivate? No. No. We'll just go straight for activate then. Well, we're not going to ls it. We're going to actually run it, of course. You must source this script. Of course you should. Dot is a shorthand for source. And so now it says we're using the same one. Oh, apparently dash version isn't valid. Dash H is, but that doesn't help. Whoa. That got upset with a lot of things, didn't it? Yeah, it's definitely a folder there. Because if I cd into source and then do pytest, it's going to say there's no tests, right? Yeah, can't find any tests. Interestingly, it does say sync.io, right? What I really want to know is why does that not find... Because this should work, right? This is the error we had last time. And it's something to do with the Python folder. If you recall, when we put the include inside of the test, it works, but outside the test, it doesn't work, which tells me that there's a function inside the test that sets up the Python path that's not available outside of the test. But I never got to the bottom of why that was. There is a way of telling it to use a Python path, right? I'm pretty sure that's what it does in here by setting this working directory. But now we've activated it, maybe this works. Maybe it doesn't. That's really confusing. Is there an async pytest in here? No. No, and that uses CHaS components agents VM, which is where we are. Okay. Let's stop right here. And I shall try and fix this so it actually works all the time. And then we shall pick up from where I left off. Till next time. Ciao.